Introduction. We have seen that a triangle has 6 parts, 3 sides and 3 angles. But to construct a triangle, you need to know only 3 parts. So we can construct a triangle using the SAS, ASA, SSS and RHS axioms. Now a question arises whether 4 measurements would be sufficient to draw a unique 4-sided closed figure, namely a quadrilateral. As a quadrilateral has 8 parts, we need to know at least 5 parts to draw a quadrilateral. Objectives. At the end of this lesson, you'll be able to construct a quadrilateral, construct a square. Construction. Constructing triangle ABC. To construct a quadrilateral, given 4 sides and a diagonal SSSSD case, let the given measures be AB is equal to 4.5 cm, BC is equal to 5.6 cm, CD is equal to 5.9 cm, DA is equal to 5.2 cm, and diagonal AC is equal to 6.8 cm. The 2 triangles we can construct to complete the quadrilateral are triangle ADC and triangle ABC. Constructing triangle ADC. Draw DC, which is equal to 5.9 cm, with C as center and radius 6.8 cm, draw an arc. With D as center and radius as 5.2 cm, draw another arc to cut the previous arc at A. Join CA and DA. Constructing triangle ABC. With C as center and radius as 5.6 cm, draw an arc on the other side of AC. With A as center and radius as 4.5 cm, draw another arc to cut the previous arc at B. Join CB and AB. Then ABCD is the required quadrilateral. When 3 sides and 2 diagonals are given, construct a quadrilateral ABCD, given that AB is equal to 5 cm, BC is equal to 7 cm, AD is equal to 4 cm, and diagonal AC is equal to 9 cm, and diagonal BD is equal to 6 cm. Steps. Draw AB, which is equal to 5 cm. With A and B as centers and 4 cm and 6 cm as radii respectively, draw arcs to cut each other at point D. Join AD and BD. With A and B as centers and 9 cm and 7 cm as radii respectively, draw arcs to cut each other at C. Join AC and BC. Join also DC. ABCD is the required quadrilateral. Construction. To construct a quadrilateral, given 3 sides and 2 diagonals SSSDD case, let the sides be AD as 4.2 cm, DC as 6.5 cm, CB as 5.8 cm, and the diagonals be CA as 6.9 cm, BD as 7.2 cm. The 2 triangles we can construct to complete the quadrilateral are BCD and ACD. Constructing BCD. Draw DC as 6.5 cm, with D as center and radius as 7.2 cm, draw an arc. With C as center and radius as 5.8 cm, draw another arc to cut the previous arc at B. Join CB and DB, constructing ACD. With C as center and radius as 6.9 cm, draw an arc on the same side of DC. With D as center and 4.2 cm radius, draw another arc to cut the previous arc at A. join CA and DA. Join AB. Then ABCD is the required quadrilateral with diagonals AC and BD. Given two adjacent sides and three angles. Construct quadrilateral ABCD, given that AB is equal to 7 cm, AD is equal to 4 cm, angle A is equal to 70 degrees, angle B is equal to 50 degrees, and angle C is equal to 140 degrees. We cannot draw this quadrilateral if we do not know angle D. We can find angle D. Angle D is equal to 360 degrees minus angle A plus angle B plus angle C, which is equal to 360 degrees minus 70 plus 50 plus 140, which is equal to 100 degrees. Step 1. Draw the line segment AB is equal to 7 cm. Draw angle A is equal to 70 degrees using a protractor. With A as center and radius as 4 cm, cut an arc on the line. At B, draw an angle 50 degrees. At D, draw an angle of 100 degrees with a protractor. Let the arms of these angles meet at C. ABCD is the required quadrilateral. Construction. To construct a quadrilateral, given three angles and two included sides, ASA case. Let the given angles be angle A as 75 degree, angle C as 85 degrees, angle D as 68 degrees, and the given sides be AD as 6.1 cm, DC as 7.5 cm. Here also we can construct the quadrilateral directly without dividing it into two triangles. Construct AD as 6.1 cm. At D, draw angle ADX as 68 degrees. With D as center and radius as 7.5 cm, cut off DC as 7.5 cm on the ray DX. At A, draw angle DAY as 75 degrees. At C, draw angle DCZ as 85 degrees. Let AY and CZ intersect at B. Then ABCD is the required quadrilateral. Given three sides and the two included angles. Draw quadrilateral ABCD, given that AB as 5 cm, AD as 4 cm, BC as 6 cm, angle A is 100 degrees, angle B is 120 degrees. Steps. 1. Draw AB as 5 cm. 2. At A, draw an angle 100 degrees, and at B, draw an angle is 120 degrees. 3. Mark off distance. AD as 4 cm and BC as 6 cm. 4. Join CD. ABCD is the required quadrilateral. Construction. Construction of a quadrilateral, given three sides and two included angles, SAS case. Let the given sides be AD as 5.6 cm, DC as 6.2 cm, CB as 4.9 cm, and the given angles be angle D as 108 degrees, angle C as 120 degrees. In this case, we do not need to construct the quadrilateral by constructing two triangles. Draw DC as 6.2 cm. At D, draw angle CDX as 108 degree. With D as center and radius as 5.6 cm, cut off DA as 5.6 cm on the ray DX. At C, draw angle DCY as 120 degrees. 5. With C as center and radius as 4.9 centimeter, cut off CB as 4.9 centimeter on the ray CY. Join AB. Then ABCD is the required quadrilateral. Constructing special quadrilateral square. Draw a square of side 5 centimeter. We know that all the angles are right angles and all the sides are equal in the case of a square. Given one side length is equal to 5 centimeters. Steps. Draw a right angle with a protractor or compass and ruler at a point A. Set the compass to 5 centimeter and cut off sides AB and AD of the square along the arms of the right angle. With B as center and with the same radius, draw an arc. With D as center and with the same radius, draw an arc to cut off the arc drawn. Join the point C where the arcs meet to the ends B and D of the sides AB and AD to form the square. ABCD is the required square. Summary. Let us summarize what we have learned. We construct a quadrilateral if we know 4 sides and a diagonal, 2 adjacent sides and 3 angles, 3 sides and 2 diagonals, 3 sides and 2 included angles. Also, to construct a square, we need to know the measurement of only one side.